G O Reilly, 15th of February 18. He had a number of problems. Primarily, his underfloor wasn't working. Historically, he's had problems with reds and sludge, red circuits being blocked, and a leak in the system. But we'll come back to the leak in the system again. That may be inconclusive at the moment. But his primary problem was lack of flow to the different areas, the reds and the underfloor and that. So we took a first look at what he had, and this page here, which is I've labelled page 1, shows what he had. So one boiler, represented by this, one pump, a little 5-metre pump, and this is just a very rough diagram. And then we had about 8 or 10 legs, all with different flow resistances to different areas. The hot water cylinder, the reds upstairs, other reds upstairs, both the bathroom downstairs, the bathroom upstairs, the front room downstairs, and then you had the underfloor and you had other reds. And they were all fed by this little 5-metre pump. And that's a fundamentally poor design, but it's not anybody's fault, because what's happened here over 50 years since the house was first built, there have been layers and layers and layers added. Looking at that diagram in more detail on what I've labelled as page 2 in the still photograph, we see a little bit more detail of what's gone on. So again, the boiler's represented here, and the little 5-metre pump, which I've just put a note here saying 9 legs fed by that. We feed out of the garage through that little wall, which you see in the still photos, and then into this first valve, which I've labelled inside in that press V1. And then after that, the first tee-off is a little 1/2-inch pipe that goes down into the ground and feeds the ground floor toilet, which is not working at present. This has been February 18. The next tee-off, as we move along that pipe, is a 3/4-inch pipe, which goes to the front room radiator downstairs. That's number 2. And as we move along that pipe again and we tee off, there's a 3/4-inch tee off which goes off to the underfloor. And then that in turn out at the underfloor manifold. Well, first thing is there's a diagram coming up on page 3 which shows what goes on here. But it in turn is teed off on a 1/2-inch to the red in another front sitting room, the one on the left of the hall door, and another red upstairs. So 1/2-inch, 1/2-inch tee. There's tees everywhere, which shouldn't be really. So already we have 1, 2, 3, 4, 5 legs teed off the one 5-metre pump flow. And then we have a main 1-inch pipe going upstairs, which in turn at one point comes down to 3/4 and goes into the coil of the cylinder. Incidentally, there's a valve on that cylinder that needs to be replaced as well, that doesn't shut off. And then we have another T-piece off that 1-inch pipe, which is 3/4-inch heading north upstairs to the reds upstairs. And there's in turn another 1/2-inch T-piece off that, which goes to 2 bathrooms upstairs. So we have in total 7, 8, 9 different legs with different flow resistances piped off that one pump, and it would be impossible to balance the whole lot and get the flows right, even if we had valves on all these legs, but we don't, except in some instances maybe red valves. So that's the fundamental problem combined with a possible sludge problem. And then just a quick look at the underfloor, the way that's done, and we might look at that in conjunction with the real life. So what we have is the flow there at the top coming from the boiler, and it's circulating around in this direction, around here, down through that, and around that loop. And in real life we see that here. I'll just pause it one sec, see if I can get some light. So in real life we have the flow in here and down through that valve there in blue, and then back through the mixer valve and back to the boiler again. And that's represented on the diagram here by this flow out down through that valve with the blue handle and back through the mixer valve. So what happens is, if the mixer valve shuts down, if everything's hot enough, we get very little flow of hot water around here, and the sensor is over there. That's it. There, the little copper thing. So we have two flows in this underflow circuit. One from the boiler supplying hot water to here, and then we have the underfloor pump which pumps in this direction around here. So one of the problems we had today, was twofold. One, this mixer was stuck, valve was stuck, so there was no hot flow of hot water. And secondly, this valve, this blue one, was mostly closed. Now it's completely open, and we were getting very little flow. So even if we had heat, we weren't getting. If we had plenty heat coming in here, we're getting very poor flow rate, so very poor heat transfer. Now we've got good flow rate, and we've got reasonably good heat coming through. It's just under 40 degrees right now, with all the reds on as well. And if we have a problem with the underfloor, it's a good idea to shut down the reds that are going off in those 1/2-inch pipes. So that's that underfloor flow circuit the way it is. It's a very old-fashioned mixing valve, but it kind of works. Okay, so in terms of things to do then, the first thing is we need to add an expansion vessel. So the expansion vessel can be added anywhere in the heating system really. It could be, it could be put into this downstairs and teed into one of those pipes, or could be put out in the garage where the boiler is. So it could be placed somewhere in this garage, but it needs to be 24 litres or a minimum of 18 litres. Then we want to replace this, as I showed earlier. This pump here is only a 5-metre pump. Really, that needs to be replaced for the moment with a 7-metre pump to try and get some flow into the legs that are getting very little. At the moment that pump is on the flow. When we replace it, we can leave it on the flow if we like, but in an ideal world the pump would last longer on the return, but that can be done at a later date when we're doing a bigger job. So that's the number 2. And number 3 then is to just redesign the pipe work. So we just want to redesign all of this stuff so that it's coming off manifolds and everything will be coming back to one place and valved, flow and return valved with pumps for the 4 areas. So we redesigned the pipe work just to have 4 major zones: hot water, reds up, reds down, and underfloor, and all back to valve manifold that can be flushed. And we can isolate different loops if we want to check for flow rates and all that. Then once that design work is done and repipe, we just need to actually do the work and repipe it all. And then when it's all redone and we've valved everything, it needs to be flushed entirely. Just pause there for a sec. Yeah, as I was saying, I just added another note there, but we need to flush out the entire system to get all the sludge out of it. And now that everything is valved, and then very importantly we need to add inhibitor, because there's lots of steel reds in there that are still causing corrosion. And then on the underfloor side of things, it would be a good idea to add a modern mixing valve if we were doing all this work, and then new flow meters to the underfloor. So perhaps that would just mean replacing all the manifold, maybe not, that's to be decided. They're nice to have. So number 6 is just a nice to have, the rest are essential.